Hello everyone, welcome to CIS 137, Class 12. Today's quote, when debugging, novices insert corrective code, experts remove defective code. So I've actually noticed this in my career. In the beginning, I definitely was adding code to add more checks and make sure certain situations didn't happen, just adding a lot of code. But now, you generally can replace old code that you know wasn't designed properly or has bugs. uh, you can replace it with a lot less code once you know the tricks of the trade. So over time, you'll be more productive when you have less code at the end of the day than more code. And this was by Richard Pattis, who's a lecturer at uh, University of California, Irvine. He seems to be a pretty knowledgeable lecturer. Uh, so yeah, I think you might even have videos on here, maybe. I don't know, but it's a good quote. All right, so today we're going to cover thinking in React parts 1 and 2, and we'll talk about the course project part 3, which is due in next Friday. So thinking in React. So all this is going to be based on the docs, the Facebook docs, uh, their thinking in React section, which is the last of the quick start I will be going into. So the idea of thinking in React is, how do you break down the page into components? How do you find out where state should go? How should props be passed? This all involves planning it out. So if you're lucky, you'll start with a mock from a designer. Otherwise, you'd have to like create your own or imagine your own mock. Uh, but if you have a mock from a designer, for example, this product filter uh, mock where the user could search for products and then it would filter it down to just those products. Uh, then you can use this to break uh, the design down into individual React components. Now, when you're doing this, you should use the single responsibility principle. So each component should ideally be responsible for just one thing. And if it ends up growing to do more than one thing, it should be decomposed into smaller components that each do one thing. So each component should be ultimately pretty simple. It should be focused on just one task at hand, whether it be displaying, um, in this case, we'll break this down in a second, but uh, if for example we have this whole mock that has the search box and this checkbox and this table, uh, this all shouldn't just be one component, because that's too many things to handle. So one thing to handle would be, for example, displaying that a football is $49.99. So displaying the product and a price, uh, that would be one thing that a component could worry about or be responsible for. So let's see how that applies to uh, our mock. So the mock should have at least 5 components on it. So if we look at this breakdown, we first have this filterable product table. So this is the entire thing. So this component contains the rest of the components. So that's the purpose of that, or the responsibility of the outer component is to basically uh, render all the rest of the components. Next, we have the search bar in blue, which handles all the user input. So it basically produces the filter that we're going to use to filter our products. Then we have the product table, which contains the header and then these category rows and product rows. And then we see the product category row in the turquoise here. It displays a heading for each category. And then product row, which is in red, displays a row for each product. So each component in here has a singular responsibility, but some of them, contain other components. So, the base component, the filter product table, is a container for the rest, and the product table is a container for the rows, for product categories and product rows. So when we're thinking React, we have to, here we go. When we're thinking React, there's a set of 5 steps it has here to actually build the app as well. So the next step is to build a static version in React. So let's actually try to recreate this. We're going to use WebStorm. So first thing I'm going to do is run create React app. I'm going to run create React app to start up a new app. This will take a minute, so bear with me. I'm just setting up WebStorm 2. Apparently I had a bunch of WebStorm windows open, so I'm trying to close them. Now I'm going to open up this new project. It's not completely done setting up, but it should be fine. I'm doing this all on a second monitor, so I need to move it over. It's coming. Alright, so while it's linking, we can still work on it. Actually, no, we can't. We have to wait for the source folders to pop up. We should be up soon. So let's look at the example we have here. So here we have some JSON, or really just a JavaScript object, or array of JavaScript objects that we're going to use as the data. So this is just like the events array you had to build in project part 2. Each product is going to have a category, price, a value if it's stocked or not, and then the name of the product. So these products are going to be passed down to the product table as a products prop. So that's going to be the first step. In fact, Yeah, it's gonna take a while. So let's edit this in CodePen so you can see it there. So the first step is getting the products data into our filterable product table. The filterable product table is just going to be the root element in our React project here, and it's going to replace this container element. Now remember, React uh, basically renders all of its goods into a single div. So this command is actually displaying it to the page. So filterable product table. Let's go to that. So filterable product table, remember, contains all the rest of the components. So it really contains this blue component, which is the search bar, and the green component, which is the product table. And then these two components, the product category row and the product row, are inside of the product table. So they'll just get carried along with that. So our filterable product table just looks like this. It has a search bar and the product table, and it's passing down the products to the product table because that's the product table needs to display the products. So we're going to pass down the products to it. Next, here's the search bar. So the search bar does all the user input. So we have the input field, we have a placeholder on it, and then we have the checkbox. We're only showing products in stock. They're using pretty simple HTML in here, I think, just to not get in the way. And next we have the product table. So the product table is building up all the rows into an array. So you see for each product, if the category doesn't equal this saved category here, then we're going to put a product category row up. So we're going to say rows.push. So we're going to add it to this rows array, and then we're going to add the product to the rows array, and then we're going to save the last category that we processed. So that way we can, if it's a new category, we'll have the product category row again as we loop through. So if you don't understand this looping logic and saving the last category, that's okay. That's okay for now. Once you take a programming course and understand loops, this pattern will be more clear to you. So this is basically loop over every product inside that products prop and create a row from that product. So it's kind of like the map that we used in the past, except this one is not producing another array like map does. This basically just loops over each product and will create a new row and stuff it into this rows array. So when we go to display it, we can, they're using a table here, which is fine. It's fine for this example. The tables are pretty annoying. It's fine for this because it'll render them and it'll line them up, and it's nice and simple. Don't need any CSS for it, so that's what we're going to use. So we have a table. That table has a header, and that header row shows the name and the price. So see name and price up here. And then for the table body, it's going to spit out the rows that we collected in this loop. So let's investigate these two subcomponents, the one for the product category row and the product row. This is definitely the most complicated component in this system. So product row, first we're going to check if the product is stocked, then we're just going to show the product name. Otherwise, we're going to make that product name red. So if it's out of stock, it'll be red. So it's basketball, red. And then we are going to display the name and the price in a table row. So TR is table row. TD is, I don't know what the D stands for, but it's basically table column. TD just means column. It's not important what it actually means, I guess. If anyone finds out, whoever posted the Slack first gets a point. Okay, so TD shows the price and the name was generated right here. So if it's out of stock, it'll turn red. The product category row is probably the simplest container or simplest component. Aside from the containers are pretty simple right now, but this product category row is only concerned with showing this sporting goods and electronics. It just has a table row with a header on it that takes up 2 columns that shows the category. So that's the entirety of our 5 components all working together, and passing the props down through each component. So identifying these 5 components could be a little tricky at first, but the idea is, again, follow a single responsibility principle. Each component should be responsible for a single thing. So user input, holding a table, displaying a product category row, displaying a product row, and then, the wrapper that holds everything together. Next, we have the props with, perfect timing. We're thinking in React Part 2. So after we have the props all set up, we need to think about the state. Now remember, in React we have props, and those are values that are passed down from above the current component. They're passed down to the component from another component. Those props, you can't change them within the component. They're not a memory. They're just a point in time snapshot of a value. So you just get whatever value comes in the props, and then you render based on that. With state, remember, is like a memory for the component. You don't need very much state in React. You just need enough state to handle everything. And then on top of that, once you have the minimal state, you can generate the rest of the values from that. So what does that mean exactly? I'm probably not being clear on that. So here we go. In step 3, identify the minimal but complete representation of UI state. So state basically should be just values that can change over time. Here you go. Here are the 3 questions that you should ask. It could change over time, and it can't be computed based on other state or props. So that's the minimal state you should have. It should be state that it changes, and it can't be derived from any other state or props. So you can ask yourself these 3 questions when you're thinking about the state. Oh, and they also had, sorry, let's go back here 1 second. So here are the possible pieces of data in the example application. This could be the original list of products, the search text that the user entered, the value of the checkbox, the filtered list of products. So if you see here, that's all the data on here. Is this checked or not? Is there a value in here? What are all the products in here? And once we filter the products by putting in, which is not hooked up yet, we'll hook it up by the end of this. Filter the products, and it's only showing basketball. That's another piece of data we need to worry about. But which ones are state and which ones are just props or derived data? So let's ask ourselves 3 questions. Is it passed in from a parent via props? If so, it probably isn't state. That's question 1. 2, does it remain unchanged over time? If so, it probably isn't state. It's probably a constant value. 3, can you compute it based on any other state or props in your component? If so, it isn't state. So the idea there is, if you have our product list, that's being passed as props, so it's not state. That product list has a certain amount of products in it. If we could have a state value that's the product list count or the product list size, and that would hold 6 or whatever, however many products there are. But we can really compute that value based on the array of product lists. We can just take that length of that array and not hold the size in a separate state. So because of that, holding the count of items should not be in state. They should not be in the minimal state. And if you take programming courses, again, it's going to be easier to identify what can be computed from what else. So otherwise, it's going to be, you're just going to conceptually imagine being able to generate a piece of data from another piece of data. So the original list of products, that's passed in as props, so that's not state. The search text the user has entered, that's going to change. That's the whole point of that search text, to be able to change. And it's coming from the user, so we're not going to be able to generate it from anything else. So that's definitely state. And yeah, it's not passed in via props. The value of the checkbox, same thing. That's user input. It has the same properties as text. Like, we don't know what it's going to be coming out the gate. It's not passed down via props. It doesn't remain unchanged. It could change by the user at any moment. And you can't compute it based on any other state or props in your component. If you could, then that means, that you could predict the user's thoughts, and your React project is more advanced than it has telepathy built in. And then we have the filter list of products, which is going to be computed based on the original list of products and how it interacts with this search text and the value of the checkbox. So that's going to be computed value. So that's not state either. So once you identify the minimal state, the next hardest part, or probably the most confusing part, is where do you put that state? And when we talked about like the child-parent relationships and lifting state up, what you want to do is have the state, if you have 2 state items or however many state items in common between components, you should move the state up until it finds a common ancestor. Or if that ancestor doesn't exist, you could create one that does hold the state. So we're going to go over what that looks like. I'm going to make a little animation here. So we have this filter text in stock only. So that's filter text is the text entered by the user, and to filter the product table. The in stock only is a checkbox, to declare if we should only show products that are in stock. Now, what we should do, instead of containing the state in two separate components, because it needs to be the same state, they need to be able to pass that on to each other. We should move it up. And there's that animation I made. That's why we have full screen right now. But the filterable product table will have the state, and it'll pass it down via props to each of its children. So what's another set of rules you can use to determine where state should go? So for each piece of state in your application, you need to identify every component that could render something based on that state. So every component that depends on that state. Then you need to find a common owner component, which is a single component above all the components that need the state in the hierarchy. So if you look at this hierarchy here, we're showing a breakdown of the components in a tree format. So the search bar is a child to the filterable product table. The product table is a child to filterable product table. And then product category row and product row are children to the product table. And you can tell which ones are children to which, based on the code. I mean, look at the code. So the filterable product table has two children, search bar and product table. And then in our chart, we show search bar and product table as the children to filterable product table. So you can also do this not only from the code, but from the mock itself. So if you look at the mock again, any boxes directly within this orange box would be considered children to the orange box. So whatever a parent contains its children is the idea you can go with. So when we find the common owner component or the common parent, that's a good candidate for where state should go. So either there in that common owner, or you could even put in another component higher up in the hierarchy. It just needs to be somewhere that has a common ancestor. And if you can't find a component where it makes sense to own the state, create a new component simply for holding the state and add it somewhere in the hierarchy above the common owner component. So it's basically saying you could just create another arbitrary placeholder or arbitrary container above everything else that maintains the state, and that is actually that's getting into territory that we're going to go into eventually, where we'll have a component higher up the chain that's responsible for pretty much all the state. That's the there's a library called React Redux that helps with state management in that way, and we'll get there eventually. But for most of our projects, we're going to be able to find a common owner component where the state can go. So once you determine where state should go, we need a way for the subcomponents to affect the state. So we need to be able to modify the state from the subcomponent. And this in this document over here is called inverse data flow. We talked about it in a previous lecture when we talked about children talking to parents. It was a lecture last week. And this, remember, involved the parent passing a function callback down to the child, then the child calling that callback when it was appropriate to pass the data back up to the parent, and then the parent would change the state based on that callback value. It sounds kind of complex, but it's really more complex than it is. It's a common pattern that you'll run into a lot in React. It's just the way components communicate. And uh, and once you wrap your head around it, it'll become second nature. So let's see this demo. Let's see a demo adding the state and then actually doing the inverse data flow. So we identified in step 3, we identified that the filter world product table should have this state. And then in step 4, we identified in step 3, we identified that there were two pieces of state: the filter text from the user, so search text the user has entered, and the isn't in stock value, which would be a Boolean true or false, which is the value of the checkbox. Then we identified that the filter world product table was the common ancestor between the search bar and the product table, both of which are concerned about the state. So the search bar is concerned with the state because it's taking the state from the user, so it needs to be able to render that value onto a text box. It needs to actually accept the input from the user. The product table is interested in the filter text and the in stock only checkbox state in order to filter the products on its table. So both of those have in common the filter product table, and that's where the state lives. And if we look at this code pin example, so here we've added the state to the filter product table. Now remember, when we have state, we can set the initial state inside the constructor. And the constructor, again, we've learned before, you just do constructor props, you call super props. So this is all boilerplate right here. And then you can set the initial state. Then inside our render, we're going to pass the state down as props to all the children that are interested in the state. So in this case, we have the search bar and the product table. So the product table had products before, now it has products filter text and in stock only. The search bar has filter text and in stock only. So these are props being passed down based on this state. So now if we go up to the search bar, we're using the props passed down, the filter text, to set the value of the search box here. And we're using this prop for in stock only to set the value, the checked value of the checkbox. On the products, we're using the props.filter text to filter out the products during this for each. So instead of if the product name, if the filter text does not exist inside of the product name, which is indicated by this expression here, or the product's not stocked and we're only looking for in stock only. So this Boolean expression may be confusing, or probably is confusing if you haven't taken programming courses before. Even if you've taken programming courses, there's a lot going on here. We're checking the index of the filter text being passed in, and if it's -1, then that means the filter text doesn't exist. And we're doing this check over here, which is using the AND operator to combine two booleans. So the product's not stocked, and it's also using this to say not. If the product's not stocked and the product should only show in stock only, then we're just going to return. So this return doesn't return out of the function. It just skips the product that we were iterating over, and it moves on to the next product. So anything that doesn't match will be returned. So this state is being passed down as props. So for instance, in this search bar, if we try to type anything inside the search box, nothing's happening. Try to click on this checkbox here, nothing happens. And that's because, props, you can't change props. You shouldn't change props. The prop value of in stock only is being fed by filterable product table, and you see it's set to false. So that becomes like a static value. If we change, this false to true, it'll get passed down. Oh shoot, I pressed the wrong button. It still worked. Okay. Then it gets passed down. Where are we at? We set in stock only is true. It gets passed down to the search bar. It gets passed down to the product table. The product table shows only in stock goods at that point. This filter is working. It's just that the user input's not being accepted, so I can't change it to false. And it's being passed down to the search bar, and it's actually checking the checkbox. You can even add some filter text in here so you can see how that would look. And the basketball was not in stock, so we have to do false here. And now we see the basketball is being rendered $29.99. That's the only thing being rendered because of this basketball filter text. If we try to change this text, not going to work. So in order to change that text, we have to add inverse data flow to our search bar, or from our search bar to our filterable product table. So how do we do that? It says right here. So this is basically what we're going to do. And let me write it out because this is a little confusing at first. So let's jump over here. So inside of our search bar, we have our states, or we have our prop for filter text and our prop for in stock only, and we want the user to be able to change these. So what we need to do is whenever the user changes a value in here, we need to pass it back to filterable product table so that filterable product table can then update the state. And when the state gets updated, then filterable product table gets re-rendered because the state changed, which means this render function is called again, which means the new state is passed down to each of our components, which then causes these to re-render, and we get our updated UI down there based on all this state. So let's look it up. So we're going to accept props, and we're going to set some stuff up in the constructor. We're not setting up state in the constructor. What we're going to set up is the bindings for functions. So first thing we'll do is write a handler for changing the search text. So say handle filter text change. And this will take an event. Generally, you can call this E or event, and that's the change event that's going to come from this input text box. The on change equals this dot handle filter text change. Now the problem with calling this dot handle filter text change right here is that when we get inside of the actual handler, the meaning of this is going to be set to the actual text box. So this is a little weird, thing you have to deal with in JavaScript that we talked about before. But in order to use a function like this and have this refer to the search bar instead of, this text box, we have to bind the function to our current class, current object. We're gonna create a constructor inside here. We're gonna call superprops again. That's just boilerplate. We gotta do that, and we're going to uh, bind the function by saying this dot handle filter text change equals this dot handle filter text change dot bind to this. Boilerplate, pretty annoying. Um, there are ways around it again, but uh, those ways I believe don't work in CodePen, and they involve parts of JavaScript that aren't official yet, but are probably going to be official. But uh, this is the way we got to do it for now. In the future, in WebStorm even you can do the futuristic way, which we'll get into as we go. So here we're going to basically accept props from the parent to indicate the callback function. So I'm gonna make sure I get the naming same here. So what they have is this props on filter text input. We can call it that, on filter text input, and call the event target dot value. The event target dot value is the value that was passed into the input. That all is really the same as straight HTML and JavaScript, where every input type will create these events, and to get the value out of them, it's event.target.value. So we're going to do the same thing with the checkbox. Copying. This isn't going to be event.target.value for a checkbox. This is actually going to be, if you look here, it's going to be .checked. So it's going to match the property down here. The checkboxes, everything else uses value. Checkbox uses checked. All right. So we also have to hook it up down here. So there's 3 places when you're hooking up these callbacks. Yeah, I worry about the constructor, the actual handler function, and then adding that handler to the actual JSX. We changed it a little bit. We did handle input. Okay. That's what we need here. Okay, we did that. Let's make sure we have the props the same. So we have on filter text input, on in stock input, on in stock input. Let's just do that. We can name these whatever we want, really, but I'm just trying to stay consistent with the example. Okay. So the props are still being set for the values and the checked, but then we have these callbacks. So now up in the filter product table, we need to handle those callbacks. So just like its child, we're going to create these handlers. So we can say handle filter text input, and then we can just take the new text. So by the time it gets here, we're not dealing with an event. We're dealing with the event's value. So the onFilter text input is going to be called with the actual value. So don't have to break it down any farther there. So in here we would just set the state. This dot set state. We'd set the filter text. The text. One little trick you can do in JavaScript, at least in the experimental version of JavaScript we're working with, you have a name same as the property here. So say we have this filter text colon filter text. We can actually break that down to or decompose it to, what would be the correct term? I guess reduce it to just filter text, and then JavaScript has some magic in there that expands this out to filter text. There's a little shortcut there that makes it look neat. We should bind this handle filter text input. So just like the 3 places we needed here, we need 3 places inside of here. So inside the constructor, we're going to bind and do our boilerplate. We're going to bind the handler to this object, and then we're going to make one for the checkbox as well. And this one, we're going to call it in stock only, so that we can do the trick again. Set state. And we're going to bind that handler. And then we're going to pass it down as props to our search bar and our product, our search bar. So TD, thanks Josh, TD stands for table data. That works for me. It's really a cell, a table cell. I feel like it should be TC or whatever, but whatever. And that's one reason I don't like the table element at all. Anyway, so on filter change, what do we call it? On filter text input. Go ahead and copy that. Equals this dot handle filter text input. On in stock input equals this dot handle in stock input. Make sure that looks good. Yep. All right. So now that change gets propagated back to the filter product table. The change gets set as the state. Here, we could add semicolons here. And then because that state changed, we're going to call the render function again, and the props for filter text and stock only are going to get passed back down to the search bar. So let's clear this initial state out again, so we're not filtering on basketballs. Then now we can search, and it's working. see what else. So we want an iPod. I do iPod. It's search isn't very robust. We have to, match the case directly. But I mean, we haven't written that much code, and it's working pretty well. We have what 139 lines, which seems like a lot, but there's a lot of formatting in here and stuff. And all of our data is here. Our checkbox works too. Gets rid of all the red. So it all just like seems to magically work, right? We just hook things together. It's very clear separation of responsibility to the point where, once we hooked up the search bar, the product table was already hooked up. We didn't need to change anything there. And now it all just magically works. That's part of the beauty of React. You have all these components and you define how they all should work together. And then once you have that coded, each one has just one responsibility. Once you code up all these single responsibilities and the hierarchy, then the whole system works. So it's when you're working with React, that's the beauty of it. Everything's modular. The search bar did not affect the product table directly. All it did was pass up the values to the parent, and then the parent dealt with the product table directly. So it was like just magic, basically. Over time, you see these patterns, and React just becomes uh, this clear way of defining your UI and how it should uh, actually manipulate what's displayed on the screen. Now, it may seem confusing to you, especially without any web experience, uh, and confusing as to why this is better than the old way. But this isn't on this page. But I'll show you another example. Let me see if I can find it real quick. If you look up thinking in React, I think it's this code mentor. It's gotta be, yeah. That video is old, so it has some old stuff in there. But this explains why thinking in React is better than the old way. How it's actually becomes less complex over time especially for bigger projects. And the idea is that in the old way you had to worry about it's like a state machine where uh, if you're going from state A to state B, uh, then that's no problem. But if you're going from state A to state B, then state C, then state D, but then state B, C, and D need to have some way to get back to state A, then you have to basically manipulate the DOM based on every possible combination of going from one state to another. So they have an example down here uh, where you're checking if an email is valid inside of a checkbox. If it's not valid, then you want to display a warning or a message saying this is not a valid email address. If the value is empty, then you want to handle it differently. You want to say it's the email address is required. If the value is valid, then you want to remove all those warnings. You don't want to have it show that it's invalid or or that it's required. So you have to then remove everything. So doing that, it can get pretty complex quickly. But in React, what we're doing when we render a component is we're rendering the component at that time. So whatever value that the state has for the email, if it's valid or not, that's what will actually affect the rendering for that particular moment. So when these values change, when any value changes, we're back to square one, and then we have to determine what that component should look like at that moment. So you can think of it like as uh, a film in a movie where each frame is its own individual rendering of that scene at that exact moment. but when you flow them all together fast enough, it looks like everything's moving around. Uh, it looks like actual, action is happening, that things are animating across the screen. If you didn't know that that's how movies worked, that's how movies work. So uh, that's that's not for this class. So that's it. So once you hook up inverse data flow, that's the entire project. You'll have to do other things, of course, like actually we have the products being pulled in as a prop to our component. But how do you get these products from the server? Well, you would use a REST API or some other API, or you'd have a data file or something. These products could live somewhere else, but ultimately they would be pulled into our filter product table and just passed in. So we'd have a wrapper component above our filter product table that would make the call to products and push it down to the product table. That's thinking in React. So it's a little complex. There's lots to digest here. This is just reading through what they have here as well. There's some more tidbits in here that are good. Make sure you know the difference between props and state. We're talking about a lot so far, but just keep looking that up. It's right here, state and life cycle, and I believe props is right here, component and props. So these two sections are good to review. And then we did, with this input checkbox thing, the input text and the input checkbox, we did what are called controlled components. And that's the pattern in React where the component ultimately only shows what is, so let's get to the search bar. So the component, each input element only shows the value based on the props that were passed in, which were ultimately the state. So instead of allowing the user to change anything, we're just setting it to a static value. And then in order to allow the user to change it, we're using these inverse data flow callback things that sound a lot more complicated than they are, but again, just 3 places. Just you need to bind the handler, and you need to create the handler, and these handlers are just calling the callbacks from the parent. They could do some transformations in here and validation before calling the parents, but we just have them calling the parent. And then the third place, we put it down inside the element itself. So when that value changes from the parent and is passed back down to the child, then we can actually update the value inside the text box. So the data has to make a journey back to the parent, back to the ancestor, and down to the child again. And that is the essence of a controlled component. The state always holds the true value for the component. And then we're just displaying that true value back to the user. So yeah. So the advantages right here. React makes the data flow explicit, that inverse data flow and the props data flow, because it makes it easy to understand how your program works, but it does require more typing. That's the beauty of React, but then, when you get into later on, there's libraries that make it less clear how your program works. So there's some pushback against those libraries as well. There's all kinds of debates going on about what's the best way to, to not have so much boilerplate code, but still have that clear data communication between these components to see how modular and clear the program can work together, all the components can work together. So yeah, so make sure you understand all this thinking in React. It's really the culmination of this whole section and how you should build things in React. So let's move on to course project part 3. So for course project part 3, you have really one task. You need to display the current temperature on your site. So if you remember from last class, making something look simple to the user actually can be pretty complex on the back end. And this is more complex than it seems, but it's not that bad. It's all stuff you've learned so far. And then for 15 bonus points, have the temperature update every minute automatically. I'm not going to tell you explicitly how to do that because it's bonus points, but I'll show you after the project's due how to do it. It is due next Friday by 8 a.m., so 7:21. Let's break this down a little bit more. So to display the current temperature, you're going to display the current temperature in Celsius or Fahrenheit. And in order to get the current temperature, you're going to get it using a REST API. So we're going to use our super agent, just like, what class was that? I don't know. But we learned in the class that how to use REST APIs. So you can go back to that video and learn about it again and try to follow along with this. So we're going to use openweathermap.org to get the current temperature, which is actually picked it because it is free and easy to sign up. There's a bunch of weather APIs. If you just look up a weather API, for instance, Weather Underground, which is one of my favorites. But the problem with Weather Underground is when you try to sign up for their API, it says like, why are you going to use this API? What's the purpose? What is your app URL? So it's very interested in like making sure that you're not misusing their API. There's other ones. This one's free, whatever. But we're gonna use Open Weather Data because or Open Weather Map because it's free, it's easy to sign up, and it works. So the idea here is you would sign in, create an account. When you do so, sorry, let me pull this over here. When you do so, it's going to have a section called API keys. Inside there, it's going to give you a key specific to your account. I'm not showing my screen right now because this video is public and I don't want to pass that key around. Don't share the key with anyone. But that key is what you're going to use in order to access the API. Now, when you get your access key, you're going to need to use in your API, but you don't want to, your GitHub project is public, so you don't want your access key to be inside your Git repository. You don't want the access key to be public. So you only want it to exist on your computer. Now the way in React to make that happen is to store the key in a environment file. And we'll go over this next class a little bit more about the environment file. But this blog right here is actually a good resource for that. So the idea is you would create a .env file inside of your project. Let me see if I can pull this up. Okay, here they come. So it would go in your root directory. So it would go under your project directory. You create a new file and you call it .env. Anything that starts with a dot is going to be hidden on your file system unless you enable showing those files. So inside of our .env file. So if you look down here, defining variables in a .env file, we're going to create a our access key in here. Now, the convention is to have your variable names be all uppercase and then equals whatever value, and then the value doesn't need to be surrounded by quotes or anything. This is all bash stuff. So we're going to create an access key. We'll just do the weather access key in here so you can see, and we'll set that equal to 1, 2, 3, 4, 5. There's going to be some long string here. You're going to copy from your from the site, from that open weather map. Okay. So we're going to say welcome to React, and then we're going to put our access key right here. So we access the access key by doing process.env and then the name of our variable. So this .env had weather access key. And presumably this will work. So let's try it out. Come on, terminal. Come on up. I can hear my fans going. My computer must be doing something. There we go. By the way, you may have noticed I updated my yarn. If you want to update your yarn to npm i-g yarn, it's basically saying npm install a global version of yarn. It'll automatically update it as well. Okay. Welcome to React, and our environment variable does not show up. Just look. So there's no need to manually import variables. They will be available automatically with the values defined in the environment during the build. Remember that only those starting with React app will be imported, and the server must be restarted to see new values. So it looks like we have to have this React app in front of it too. So that's a good lesson here. React app weather access key, and then we can use our React app weather access key. Never actually tried Control C that. I actually tried doing this without using .env package. So yep, it works. Sweet. Okay. So that's the rule. So if you want React app to include, or if you want the environment variables to be included into your React project, you create the .env file in your project folder, same file as same level as .getignore, same level as package.json. You call your environment variables. You have to start them with React app, and then you could use this exact one for your weather access key, and then you just equal whatever value that the open weather map gives you. So there it is. Welcome to React 1, 2, 3, 4, 5. And if we change these values, these don't automatically get picked up. In order to get that value to show up again, that's only red at the beginning. We have to do yarn start again, and then it'll pick up the new value. 1, 2, 3, 4, 5, 6. Again, if you want to stop your project down here, Control C. I don't know if I've said that. Or you can hit this red X, but Control C is better because it just keeps you in that terminal. Okay, And then once you do that, there are more slides here. You need to call the weather API, and you should get the weather by the zip code for which is all available here. You see by zip code. So we have api.openweathermap.org/data/2.5/weather (zip equals 21157, US). I don't think the US is really needed. And that'll give you a response like this. If you see here the temperature, so this it looks pretty condensed. So let's copy all this, go to jsonprettyprint.com, paste our JSON in here, pretty print it, and now we have separated into lines. So we can see our structure better here. So our temperature is all the way down here. It's 277.14 degrees Kelvin. And this is inside the main element, and it's a child inside of main. So main.temp is the temperature. Now remember, I want you to display the temperature in Fahrenheit or Celsius. So I made a component for you to do that conversion. So you're going to be importing this component into your project. It's actually a collection of components called CIS-137 components. But it's currently just one component that you will use, and that's the temperature converter. So to actually use this, first you have to do yarn add CIS-137 components inside of your project terminal. Then you have to import temperature converter at the top of your, whatever component you're using this in. And that import statement would look like this. Now the reason we have the curly braces is because the CIS-137 components is going to be a collection of components. So just like how you can import, I wish I could find that example real quick. Yeah, let's find it. So up here we have import React and import curly braces component from React. So what this is saying is that React is ultimately this object here. And React actually has a dot component inside of it. So we could say React dot component here. But by doing these curly braces and putting the component inside of here is an operator that will take the property from the object, the React object, and give it its own variable. So component becomes its own standalone variable here. So that's the same idea with these curly braces on the temperature converter. There's really an object that could hold multiple components, but we're just tearing one of them out of that collection of components by using these curly braces. So then when you want to convert to Fahrenheit or Celsius, you just pass the Kelvin as a prop, and then you say what unit you want to convert to. So F is Fahrenheit, C is Celsius. And there's also this can run storybook with yarn run storybook, and I'll show you that. So if you can actually download this project and run it by running this command. And if you run that command, you'll end up with this. Let me pull that up. So this is that basically a version of that Git repository. Yarn run storybook. We're going to start storybook command, and this won't open the browser for you automatically. That's the only problem with it. So you need to open localhost :6006. And here's the storybook. So we can see our temperature converter working. It's passing 300 Kelvin to Fahrenheit. Here's 300 Kelvin to Celsius. You can add prefixes in here, or you can set a custom class for the temperature. And these are all examples inside of, if you go inside here, you go to source, you can see it here. Example usage, more can be found in stories/index. Stories index.js shows how to use that temperature converter. So temperature converter uh, for 300 Kelvin to Fahrenheit, it just shows Kelvin equals 300 to unit F. If you want to add a prefix, temperature converter, Kelvin 300 to unit F, prefix, the temperature is. If you want to set a custom class, then you can just set the class name like anything else. And that'll pass down the class name to the element on the temperature converter. If you're interested, you can also look into the temperature converter, which is under SRC source components temperature converter. So this basically, takes the I don't know how this basically got in here. So it takes the oh, everything is, there shouldn't be spaces in here. It's not displaying some stuff. Wow. I don't know why GitHub is not displaying the code. Very interesting. There should be code right here that takes the Kelvin and the 2 unit out of the props, and it takes these other things and the prefix and puts it onto the element. But you see it's converting the Kelvin to a unit. So that's actually calling this method up here, converting Kelvin to unit. Based on the unit, it's calling the Celsius converter, the Fahrenheit converter, or the Kelvin converter, which just returns Kelvin. Or an error if the unit value is not CF or K. So that's all the temperature converter is doing. And that was the demo of the temperature converter component. So one thing about the weather REST API, it's not clear from these docs how you're supposed to pass the access key, but how you should do it is seeing if I can find it in this in the API here itself. So how to use API key. Here we go. How to use API key. So to get to access the weather API, you have to use API key, and the activation takes 10 minutes. So this is important. You're not gonna be able to use it right away. So make sure you access it, and then go eat a sandwich or something and come back, and then it'll be ready to use. This English in here is terrible. We keep right to not to process API requests without the API key. I don't know what that means. That doesn't make any sense. I guess that, you can not use the API key and then they won't process it. I don't know. But anyway, for any request you make, if you have your zip code here, you need to add this and app ID equals and then the value of your API key. And in React, this will be the process.env.react_app weather API key, or whatever you want to name it. So look down here, and you see that and app ID is just added to the request. So that's just something you have to tack on to the end of the URL when you're making that request. If you have any trouble with that, please contact me. It's simpler than it seems. There are a lot harder ways to do authentication, which is another reason I chose this Open Weather Map REST API. This is a very simple way to do authentication, or not really authentication, but authorization. So there are some limits to the API. Whatever, we're not going to run into them. If we do, whatever, it's not a big deal. It'll still be free. So again, display the current temperature on your site. We'll leave it up to you onto where you display it, but it should be obvious. 15 bonus points to update the temperature every minute, due next Friday. And also remember, if you complete all of project part 2 inside of project part 3, which was adding those 3 sections, having React Router be able to navigate between those 3 sections, um, then you can earn up to a B for course project part 2. Just submit that URL to course project part 2 as well if you haven't done so, and I'll grade it. So if that's what you intend to do, you definitely still have to submit the course project part 2 assignment. But once you do, I will grade it with course project part 3, and you'll get credit for course project part 2 as well. So you can get a 2-for-1 special if you missed out on part 2 for some reason, or you're not happy with your grade in part 2. And remember, last class, I went over exactly how to do part 2. So adapt that. Feel free to take that, adapt it, uh, make it work for your project, and incorporate it for part 3. Okay, so that's it for today's class. I hope you all have a good day uh, and a good weekend, and I'll talk to you all on Monday. Bye bye.